All right, welcome everybody. Tonight is the 17th of August in Dallas, or I guess the 18th of August in places closer to the other part of the sun's rotation on the Earth. Anyhow, this is Dallas Personal Robotics Group Robot Builders Night Virtual, and we simply go around the table and talk about our robot projects. At some point when we get a little more of a quorum, we will have probably more of a discussion on our upcoming big event this Saturday, which is a contest, outdoor rover contest. In case you're watching this on video, I'll briefly put up a screen with the deal. The details you can find here. We'll put these in the chat for the meeting as well. But we are having attendees in person in Dallas, observers from Seattle, and at least one competitor from Ontario, Canada, coming up just this Saturday. So it should be a lot of fun. It'll be our first event since in person since COVID shut things down in March of 2020. So we're real excited to get things back rolling again. And with that in mind, just start into the regular routine. We'll go around the table. And just so you can remember the order we have queued up, we'll have Doug D first. And in queue after that, Pat, Ted, Doug P, Dave Ackley, and John G. So with that in mind, probably by then we'll probably I'll be ready to talk about some logistics questions because there've been a couple of emails and plenty to talk about for the contest. So unless there's any other pre-meeting housekeeping, Doug D, best cat dad ever. Take it away.
Well, I got that shirt from my daughter because I was taming some feral cats out in the backyard, and I wore it in Murray's honor because he has a cat who's always being nice to him. And also in Murray's honor, I got this little toy because last week we had talked about my robot motor problems, and y'all had suggested I get the Pololu motors, and they were 12 volts. So they don't, I don't have any 12 volt stuff. So Murray uses these kinds of things, and I got this to attach to that. So that'll get me 18 volts. And then, because 18 volts doesn't equal 12, I went back to Pololu and I got a buck converter that hasn't arrived yet, but it should be here any day now. And then I'll get the 18 down to 12 and have it nice and filtered, and I'll be a happy camper about that. And I've got these humongous wheels from Pololu to go with their motors, and that'll drive my telepresence robot. And with any luck, it'll be up and running soon. Not in time for Saturday. So that's my update.
I have a handful of Ryobi batteries too. So where did you get that particular widget from?
Okay, that widget I got off of Amazon, and let me peek over to my open screen, see if I have that open still.
That seems like something that could be 3D printed also.
Yeah, I don't have 3D printers, so.
Yeah, I don't currently have it open. I can put something in the chat.
Well, what are the keywords? I mean, what is it called? Sometimes just.
I wish I remembered.
I'll get back. It wasn't Murray that suggested that, was it? Heaven forbid.
Murray has.
Can we adapt them, maybe?
If you want to.
I think I found it.
Yeah.
The ones that I've been using, these are Makita batteries, and Makita sells a variety of these clip-ons, and I actually hack them. So there's just 2 screws, and you can actually open the thing up. And I just soldered a standard 2.1 millimeter. I don't know, the light's not really good, but yeah, there we go. I just soldered a 2.1 millimeter power jack hooked to the terminals inside. It's dead easy. It's like a 5-minute job kind of thing. And these clips in New Zealand are really expensive, but in the States they're like 30 bucks or 20 bucks. And this is an ADP 05 or an ADP 08. And then there's also, if I can find it, I've got everything all over the place. There's also one for the 12 volt batteries, the smaller 12 volt batteries, which is a YL 0000003. and that's actually a clip holder for a powered, what do you call it? It's a powered vest for keeping yourself warm in the winter when you're working. So this is it's a little 12-volt battery clip that has a cable that plugs into the vest to keep you warm. But basically, Makita sells a bunch of these different clips for different purposes. This one has a 5-volt regulator on the side of it as well, like for USB, but I don't think it's very good quality. I mean, it's for charging phones. But anyway, the Makita ones are easy. I don't know. The other ones have those big posts up the top, which I didn't like. Anyway, batteries.
Yeah, so I found it yeah, it never occurred to me, Doug, to look for that on Amazon. I think the keyboard there seems to be Power Wheels adapter for some reason. I guess people use it with those little cars for kids, you know, instead of a car battery or something. So Power Wheels adapter.
So just
seems to be going for $15 or so. I think I gotta look into that. Could be useful.
Yeah. Just as a side note, since I've decided to go with these batteries for my 12-volt solution, and I'm going to have more than one 12-volt requirement because I'm going to do other things beyond the telepresence robot, I went on the Ryobi site and I was saying, let me get some extra batteries. So I looked up the price of 2 of the batteries that I wanted. You know, they're big ones. And turns out they're having a humongous sale right now. And you get 2 bags full of a whole bunch of top power tools with the 2 batteries for the price of the 2 batteries. So if you're interested in power tools, Ryobi Direct has a really good deal right now.
Could you put that link in?
Yeah.
If you have it.
I'll pull it up and bring it in. I was major surprised.
Do you know the dates? I was going to say at Home Depot they had it too.
Yeah,
I'll look
that up. I don't remember details so good anymore because I'm a senior now. I count on my computers remembering those things. I'll put something in the chat. I'll relinquish the table to whoever was next.
All righty. Cool. Thanks. I think we had Pat in queue.
Good evening, guys. So it's been a really eventful week for me. Retirement sort of sucks because all you have to do all day is work on robots. And that doesn't give you any sort of happiness when things go just plain wrong.
Oh.
It's been a horrible week. I made a list. Started off last week. I was talking to you guys about my MQTT message server. Had a huge lag in it. At one point, I was up to 30-second lag. Happy to report that is working very well or well enough. It was the way I was calling a couple of the client.loop functions. So there's 3 different modes, I believe, for calling client.loop. Client.loop, client.loop start, and client.loop forever. And I was calling the client.loop with a time interval. And I decided I changed it to just the client.start, and that resolved client loop start. That resolved my problem. My communication speed went up dramatically. So which was a good fix, and I found that fairly early in the week. While testing, my motor driver started becoming intermittent. Started different wheels, left side, right side, wouldn't respond right. Just progressively got worse and worse over the course of a morning, to the point where it was non-functional whatsoever. Looking into it, did a whole pile of tests and checks and looking at stuff and wiggling things around, and decided that it was the cheap little riser connectors between the boards. And I ended up ripping off all of the riser connectors, unsoldering everything on the 3 Arduino, the 2 shields and the Arduino board, and I put in some number 18 solid wire between all 3 boards. A lot of work, especially getting all those pins lined up, trying to get it all soldered in there and through and boards level. But that's working very, very well now. I'm not having any communication issues between the boards. So that worked out well. The next one was my GPS. So I had a little USB GPS unit, a U-Block 7, I think it was. and it was working really well. And it just, all of a sudden, just refused to connect. It won't get a fix on any satellites. So it's trying, and it won't get a fix. And it's the same on my laptop. If I hook it up to my laptop, try to get a fix, it's the same thing. I'm just not getting a fix. So I tried it in the middle of the backyard, no trees around, just not working out. So everything has been going against me this week. So Ted had sent me a BNO 55. I've got that working. So I've got that on the I2C bus on the Raspberry Pi. I dropped my clock speed down so that clock stretching won't be an issue. Clock pulse stretching won't be an issue. And I am getting readings out of it. So that's a good thing. I don't know how stable the Euler readings are on it as far as to get a directional heading, but it gives me a start. So I know that when I power up the unit, I face the robot north, I power up the unit, I get a Euler angle of 0, 0. And as I turn the robot and move it around, I'm pretty much following the compass heading. So that seems to be working good. I was relying on GPS to give me a position. I'm in the process of rewriting all of my routines to XY coordinates. So basically taking in GPS coordinates, latitude, longitude, converting them to on an XY plot to different positions. So at the beginning, I'll find out all my target positions on the XY plot, and then basically have the code follow through and go from position A to position B that way. So that's what I've been doing right now. So instead of actually running and testing and fine tuning stuff, I've been rewriting my navigation program the last 2 days.
Hey, Pat, do you have an external antenna on the GPS unit?
No, I don't.
Oh, okay.
So just a little $13 unit I bought. I did have a little serial one with a small little external antenna, a little ceramic block antenna, and I had no better luck with that.
Oh, really? Huh.
So, and then I have a handheld GPS that works, and I could get it to work. The problem is that on startup, the Raspberry Pi kills the power to the USB, and the GPS won't automatically reconnect after that. So where I can get good stable results out of it, it won't survive going through a reboot. So that's what I've been working on. So it's been a lot of fun this week.
Lots of integration there, Pat.
Yeah, so I did have it out in the front yard, and I had it going around, and it was doing what it was supposed to be doing. It just wasn't getting a heading. So it knew that it wasn't on the right track, and it was constantly adjusting to pull to the right. Say, okay, well, go around and try to get back on track. Except the heading never changed because my GPS wasn't updating anything. And so it just kept going around. At one point, it did a really nice job of following around my flower bed. That's it for me. I'm on a mad scramble for the contest Saturday.
I think you and probably a half dozen other of us are on a mad scramble.
My backup plan is to just basically say, travel for this many pulses in the forward direction and hope for the best is my backup plan.
Yeah, that's a common algorithm I'm hearing. There might be something like that going on here, I would think. Just kind of sort of, okay.
Yeah, I've been there, Pat.
See, there's not quite any camera yet on this one, so. Okay.
Well, I've got a camera on it, but I'm not really relying on the camera till I'm supposedly getting closer. So once my distance is under so far to the cone or where it thinks the cone is, it'll power up it'll start listening to the camera routine for doing the search.
Nice. Hey, Doug D, can you speak up and get your image on the recording there? What are you showing?
Yes, I haven't tried this yet. I just got it in from Amazon. It's a BN 880 GPS / compass. and I was looking at a blog from DroneBot Robot who gave it a pretty good review, so I thought I would try it. It doesn't seem to have the problems that the IMU type units have been having. So I'm going to give it a try on my outdoor robot when I get to that point, which will definitely not be by Saturday. And I'll give you some more information on it, but y'all might want to check out that DroneBot video and see what he says about it too. He actually reviewed about 5 different ones, and I like this one the best because it had a compass.
Can you put that into the chat?
I will put that into the chat.
Thanks, guys. That's it for me.
Okay, cool. Very good.
I do have one more update. So retirement doesn't last long. My last day working was June 28th. I had a month of vacation, and I've lined up a part-time job on a casual basis. I couldn't say no to the money. So Sunday I leave for 2 weeks.
Oh no! Oh my!
So heading to Eastern Canada, New Brunswick.
Well, that should give you enough of the cryptocurrency to pay for some more robot parts.
Oh, definitely will. So
excellent.
I'm going to work on it for next year, though. I'm going to try to get your 65-pound limit for a robot upped.
Ooh, that sounds exciting.
You got to play with the big boys. We want to be in the 120-pound class.
Very cool. All right. Thank you, Pat. Very good. So then I think, Ted, you were next in queue.
Okay, yeah. I've got some updates. I went and added the bumper switch like people suggested, and that's working well enough. I'll show you what that looks like here. Let's see. There we go. And I got a little video so I don't have to try to hold up to my laptop screen. But anyways, I added some bumpers on the back and a little door to get to the controls on the inside. And then, so this is the bumper switch I'm going to show you here. It's that little green switch on the right side. And that's kind of how it works. And now I'm going to just show a little test run of it going to the cone. I only had one issue where I was increasing the speed to see how fast I could get to the cone, and I hit a bump in the grass and it jostled the bumper and triggered it. But if I go nice and slow like this, it seems to work. Pushes right up against it and then backs up. So then I have another where I just made, thank you. I just made a short run in my backyard. I think it goes out 15 feet, then turns and goes 40 feet to find the cone. And that actually works surprisingly well. I haven't done anything like a 100-yard test yet, which may or may not go so well. I plan to do that later this week when I get a chance. My concern is I have to get within about 12 feet for it to reliably find the cone on the camera. And, you know, if the cone's 10 yards away from where I put the coordinates, it may or may not find it. But I have a little trouble with the control of it. It seems to like to wander back and forth as it goes, but it generally goes all right. So here it is going back to the fence, and it stops like 4 feet from where it started, so it's not too bad.
Real nice.
Yeah, thanks.
Yeah, that's a lot of progress, Ted.
This Delta 3D printer is the Super Racer.
Yeah, so I'm happy with that.
That's in range. That's pretty cool. And you have a long drive too. I mean,
yeah,
coming
12 hours.
My goodness, that is gung ho. I mean, in terms of effort, and you have a day job. You're not retired like some of us.
Yeah.
I'm not speaking for myself because I'm not retired, but that's really impressive. That's above and beyond, Ted. That's cool. Okay, good.
Yeah, I was lucky enough not to have anything, motor drivers die or any components die this week. So I'm still crossing my fingers that nothing just falls apart on me, but we'll see. So yeah, that's it. Who's next?
Are you using an IMU, Ted?
I am. So this is totally gyros and wheel odometry.
Okay, gyros and wheel odometry, no compass headings. You're just using the odometry.
No compass heading. So that's one thing I have to be careful about is getting it lined up on a known heading when I start. I'm using the same B&O 055.
Yeah, that's I found it's very on startup. It's very reliable to find 0.
Yeah.
So if I point it north on startup, at least I can do a spin and head off in the right direction. So I might have to turn around and like the place I'm looking at using, it would point away from the target, essentially, I'm thinking. We'll find out. We'll find out what Doug gives me for coordinates.
Yeah.
Cool. All right. Speaking of Doug, that takes us to Mr. Doug P. I think you're next in line.
Okay. Well, like Ted, I've been working on mine pretty feverishly. And sort of like with Pat, I've had some successes. And I've had some things that took me back. I finally got them fixed, but it took me back for a long time. So I'm gonna go to a presentation here, just show a few little videos. Okay. At least I hope I am. Okay, this first one is me. Okay, at this point you can see I've got it now. The wheels, the steering tracking the cone. Before I showed you that the Pixie was seeing it, but now the steering is actually tracking the cone. So that's pretty much what's going there. You can also see the oscilloscope, you can see the signal changing. So working pretty good there. So that's the thing. You can also see I reworked these. Let me go back. Stop. You can see I reworked the bumper too. Now, turns out that when this is running through thick, heavy grass, that's really almost at the grass top. So I may move this bumper up to this area or up on top, but instead I wanted a real sensitive bumper, and I'm going to rely on my ultrasonics to keep me from hitting trees. This shouldn't break if it hits a tree, but you know, I'm more worried about this guy breaking over here. So anyway, so one victory. Now I've got steering working fine with it. And then this one was a real biggie. This is the autopilot sending messages through to my Mega. So I'm actually picking up, and if we go there and we take a look at that, stop it. So I'm getting about 5 times a second. I'm getting the waypoint distance in meters. I'm getting the target bearing and the nav bearing. I'm also I'm getting other things too, but they're like, I won't be actually using latitude and longitude, but it's giving them to me. And there's another, the one that I'm really planning to use is this waypoint distance. And that gives me, there's one other message that I get is that when I finish a course segment, it will say, okay, I'm moving to the next waypoint. And at that time, when I get that message, that's going to be when I'm going to switch to the Mega. I may also use, like I say, the waypoint distance. I haven't made it. This is all assuming I haven't actually gotten the cone. All right, so those were kind of the good things. that happened. Let's see, one went up. Okay. The other thing that I had one big disappointment, and it took me a little bit to figure out. On my GPS, you know, I'm really going to be depending highly on those ultrasonics being out there pinging. And they work great, except every once in a while I would lose one. It would just stop. At first, you know, I did okay, I moved this wire to this one and this one wire back, and it seemed to follow that. And that was a false lead. What was actually happening is, I think because all three of them are randomly going off, they actually can write over they can actually have a situation where two pins trip it. One trips while the other one's still in the interrupt. All right. And it'll handle it, but the problem is it loses the trigger. So the solution was, if I haven't gotten an update on a particular sensor in 40 milliseconds, it just sends another trigger, and that's fixed the problem. I'm all good there now. So, and I want to show you. This is what it's going to look like. There's all. I've put a little car cam on the side so I can take a running shot of it as we're going down the path, and pretty much that's what's going on there. And but I still got some routines that I need to walk to get to where Ted is. One of the problems I'm trying to figure out, there's two ways I can approach turning this car. One is to do a gentle turn. Okay, this is assuming I'm at somewhere near the cone, but I haven't picked it up. I don't know where it is. I'm just somewhere near. So I can either gently turn around and try to do a circular, or I can do a turn and go back. And I haven't decided which one of those I'm going to approach yet. I may use the turn and go back because that's probably also the one I'll use to try to get around obstacles that I run into along the way that weren't part of my planning. So that's where I am. Still got a lot of work to do. I've never been this close before, so I'm hoping to be able to do okay when I get out there. So that's pretty much. Was there anything else? Oh, the only other additional part that I'm going to add, and this is one of the things is it's hard to know when different things are going on, especially when you're testing. So what I'm going to do is add this little strip of LEDs, and they will be status lights. So like when I get that message that I'm near the cone, one of them will come on. When I actually spot the cone, even though I have LEDs on my Pixie tracker, this one will also pop on. Things like that. When I get an ultrasonic obstacle, so each one will be assigned as a flag to a different object or a different part of the process. That's the only new part I'm going to add to it. And it'll be across the back. So that's where I am. Oh, so nobody's mentioned anything. Look at my new camera. I'm clear. I don't have the big shiny spot on the top of my head.
Oh yeah, nicely done. So which one did you pick? How'd you do that?
I went out. Too. Yeah, I went out and got I said, having the worst cam in the whole group, I decided it was just time for me to get upgrade. So Micro Center was having a $5 sale on $5 off sale on a creative live cam. So I picked it up.
So Doug, I did end up raising my bumper up higher because I was also having trouble hitting grass and stuff on the ground.
Okay.
So.
Well, here's how I'm handling it now. Just so.
Okay.
First of all, there's enough resistance that it seems to be okay. But the problem that I have with so what it does is the bumper is running through the loops real quick. It's outside of the PID loop. So when if a bumper gets hit, it counts up. And I have a number of counts that it has to reach before I actually trip. And if it gets a non-count, it goes down one. So it's sort of like a leaky integrator, but I'm not resetting it to 0. Because what I found was that you do occasionally get that glitch, and if it sets it back down to 0, then you have to count back up again. So that seems to be working real well. One thing I wanted to show, and I can't show really nice pictures like Ted of it running, but so you all know these RC cars run like a bat out of hell. So right now it's booting up. Okay. So you can see that's running at a reasonable speed under PID control. I may have to, this would be the speed I might be going at near the end. Can you guys see that?
Mm-hmm. Yeah.
Yeah. So now you might see a little jerk every once in a while. Part of that is the T-bones. See, I got it up on a stand, so the wheels are sagged down as far as they can, and they're having a little interference with the T-bones on the back. If you look at the front wheels, you see you don't have that problem. But it's so my PID loops are working good. That's it.
Ted and Doug, I thought you would extend your bumper across your front wheels. Did you both decide not to do that, or?
Well, okay, that's the way it used to be, Ray. And then I hit something.
Oh.
And the problem is you're only supported, say these 2 fingers are your supports. And if your bumper is way out like here, the moment on that is like really big. And it just you're going to, the bumper's going to tilt. It's going to be a real mess. Now, Ted's case, he's got, I think those supports spread out a little bit. But
yeah, but mine still don't go past the wheels.
Yeah, yeah. But ideally, when I make my 65-pound robot, next year, it's going to go past. It'll go past the wheels, and and then everything that will get, they'll get caught on the spikes in the front. So, but that's a different robot. This one here, right now, just pray I don't hit a tree.
On my 500-pound robot, I'm going to put Ray on front as a bumper.
Yeah, and when he squeals, that means it's activated, right?
I have a real smart bumper.
You don't even need a switch.
That's the point of anything, a 65-pound robot, is you don't have to worry about any trees less than 1 inch in diameter.
Yeah. Well, I'll tell you what, the last time I took this guy out, I had a different motor and a different speed controller. It had the stock motor in it. And it went like a, it was, you got it and it was like you had to run to keep up with it. And it went from the second cone to the first cone to the second cone. And even though I tried to waypoint everything out, the second cone was under a bunch of trees. So your GPS becomes less accurate. And it's not that accurate to start with, only like 10 yards. So, it just went whoa, right into a tree because I didn't have any obstacle avoidance at all. And I said to Ray, the bumper did save the front chassis. So, it probably saved a lot of damage. But my goal this time is to go slower and also not hit anything. So
do we know what the grass is going to be like?
Well, okay. I would say normally, I've been out to his house. He has some areas that are lawn, but I think the place where he showed us, where he kind of wanted us to be, where he was going to be, is kind of sparse grass, I think. But it could be, how grass can be in a clump, pretty heavy clump. But you could run into clumps of grass. That might be a problem.
He said he was going to mow it well for us.
Yeah.
What that means.
Yeah. But I mean, it's probably just, my backyard is the thick grass, whatever it is, real thick. Not
St. Augustine.
Yeah, St. Augustine. And it's really thick, and that really slows you down. I mean, that really makes the motor work. And I don't think it'll be that bad.
It may be swampland.
Yeah. Well, that might be true. I mean, wouldn't be surprised if there's a gully or two or something.
Because 3 days of rain may be a little too much.
Yeah, well, that's the other reason why I haven't had my robot out in the backyard as much, so I couldn't show you anything, was because we have had 3 days of rain. I couldn't believe it. I mean, August rain, that's almost doesn't happen,
Bring your farm and ranch boots with you.
Yeah. So anyway, we'll see how it goes. But like I said, I've never been this close before. So
you can get there, Doug. You're on the edge, on the cusp.
Yeah.
All righty. Okay, so we have 2 more people queued up. So think whoever wants to jump in after Dave Ackley and then John G. So get yourself ready and get ready to raise your hand. But next in line, we have Dave Ackley with something. What you got, Dave?
Okay. I remember one of the times before somebody was talking about wanting to have control of the current for their motor. And I came across this. Let me see if I can get this copied and put up. Okay, here's the website that discusses this part. What it is it's a standard full bridge driver, but it also has a current sensing pin that is, I think it's 100 microamps per amp or something like that. And if you put a 10K in series with that, it'll give you at 1.5 amps driving into the motor. When it detects that 1.5 volts on that pin, it cuts the power off. And so the idea is, and if you look at that, it'll show you, it talks about it and shows you some waveforms. Basically what it does is it clips it at that point. When it cuts it off, then it turns it back on again. And so it sort of oscillates around the 1.5 amps until the current drops down to the point where it's not limited anymore. And so anyhow, that's when I stumbled across. That part is the MP6522. And it looks like it's an interesting part. Mauser, who is one of our local distributors, it's going to be $2.78 each. So it looks reasonable.
Did you were you sharing something on that?
No, well, I put the website there.
I don't see it.
Didn't show.
Didn't show? Well. Huh.
Oh, there you go.
Okay.
Cool. Hit enter.
There you go. Yeah. Anyhow, it looks like an interesting part that somebody was mentioning that they wanted to be able to limit the current to their motor. And here's a perfect example of that. And the other thing I was thinking about is that one could actually do that on most of these full bridges, because most of the full bridges do have a pin that you can sense the current on. And if you put a comparator on that pin, then you could, with some logic, cut the drive off. So you could actually do that outboard with some logic. Anyhow, that's all I had.
That's pretty cool.
Thank you for researching that, Dave.
Yeah. Very good. Well, thanks. And how's that for a segue? Next we had in line was John G. Anyhow, you have an update, and now you have more parts to research for us.
Well, yeah, I'll look at that. But what's the fun in that if you can just buy it? I did a do-it-yourself solution, and my current limiting actually works fairly well with my little custom motor driver. The thing I was playing with now was my PID control algorithm within that driver, and I built myself a little test rig to see if I can. So I can play with the PID parameters. I've got my control board on the back of this, mounted on the back of this little test rig, and then I've got my Kololu motor you see right in the middle. You can see the the magnetic encoder, and then limit switches on each extent of the travel of my mechanism, which kind of mirrors what my spider robot will do. And then I've got a Raspberry Pi Zero mounted there for controlling it. And I was just playing with that today, and although the PID control isn't really necessary for my spider legs, I kind of wanted a generic motor driver board that I can use in the future for other things. So when if I found that the PID is useful, I would go ahead and do that. And I had this hooked up to my BitScope oscilloscope here, and playing with the proportional and integral parameters here. You can see, I drove it up to one limit and then back down to another, and you can see the overshoot and the correction here. And with different, with a larger proportional and smaller integral parameter, you can see it runs right to the target destination. This curve here, there's actually I have a rotary position sensor that's basically, it's a potentiometer mounted on one of the shafts of this test rig. And all I'm really doing is measuring the voltage across that potentiometer as a substitute for position. So this is essentially a position graph when it comes to the motor control. So that's what I've been doing.
Well, that's looking pretty good.
I have a comment that I just want to throw in so that some people might not know about. This is the standard L298 motor controller that you see for a couple bucks that everybody has. Okay. It comes though, that the 298 actually has current sense resistors in it. I mean, current sense, the option for current sense resistors. And if you buy this particular module and you look at it, and it's different, you can find them on eBay and you can find them on Amazon and everything. They're a little bigger, but they have a row of connects on the side. And on those connects, they expose CSA and CSB. So if you wanted to just screw around for not too much money, you could play with this.
It looks like a SparkFun board. Is that SparkFun?
No, it's a Chinese board. This one's called Hex. So, but they're a little bigger. They have. Let's see if I can get it where you can see this on. Take a look at this when the video gets posted, and you can go on to Amazon and see about it.
Doug, it's focused more on your head than the board, so yeah.
There you go.
Maybe a link to it would be helpful in the chat.
Yeah, if I can find one, I'll take a quick look. But
okay.
I'm just saying people don't. The reason why people don't realize it is because the standard L298 board doesn't give you access to the current sense. It's the pin isn't exposed. So that's why you don't see anybody messing with it. But just anyway.
And Doug, Molly gave you an idea for focusing. If you put your hand behind the piece, maybe the camera will focus on the piece instead of.
Oh. So that's what it looks like. And the key is these guys right here. That's where it's exposed.
Yeah, you might need to cover your face, but okay. Practice.
Yeah.
I've got one other thing. Did people see my chassis dynamometer pictures before?
Yes.
Okay. Then skip it.
Well, wait a minute. Maybe I'm missing. I'm new.
Not sure. Yeah.
Is this something new? Now. Yeah. Is this new, David?
Well, here. Let me see if I can present it.
Oh yeah. Okay. Have you actually used it on that robot to tune it?
I've used it a bit, but I need to. I've had a problem with the tuning in that the period. Well, it doesn't run fast enough for me to record. The recording, so I have to. What I was doing is outputting the data on a USB serial, and that took too much time, so it was messing up the loop. And so what I'm going to do is to spool that information off to a memory, and then dump the memory afterwards.
Or you can use, I'm not good with this technique, but I know there's others that could, you can use DMA to do that.
Yeah. Well, basically I was trying to do it dirt simple and put it out on the serial port, and took too much time to put it out on the serial port, and it was screwing up the loop.
Yeah.
I want to point out that someone in the Discord help channel asked for help with the PID tuning. So if anybody's kind of a master at that, you might look and see if he wasn't specific about what his problem was. He just kind of generally raised the issue of, hey, I'm having trouble with Ziegler-Nichols tuning, and that was all he said.
Yeah. Well, in that picture that I showed, the pots there on the top were essentially the tuning parameters, so you could easily adjust the things. And since it was stationary, although it was driving, you could tune it right there in place. But like I said, I was trying to also output data, and that screwed up the loop, and I haven't gotten back to fixing that problem. It's on my push-through stack of projects.
No.
Yeah, I can't tune the fish.
What do you say, Ted?
I can't tune a fish.
But I can tune a piano.
Okay, well, cool. All right. Let's see. Well, at this point, maybe we'll take a brief detour for the Saturday's contest. And I'd like to ask, is there anyone on the line who intends to go either in person or virtually who has not put their name in the list so that we can get a tally and head count? So Ray and Ian, could I get you guys to just put your name in a spreadsheet or send an email in so we can, I'll put the link, I'll put a link straight into the one tally sheet. That would really help. That would help. because we're going to order food and we want to make sure we have enough, and we want to make sure that we can. There's the register place.
And Carl, you should have mine right in there. That is on the event, right? I did that, in other words, but I didn't say anything back. So I did find the address, by the way. So don't need to worry about that.
No, yeah, you're listed. I mean,
Okay.
so we have a lot of the guys online here, but I think not too many observers. But we just want to make sure we have enough food, and we want to make sure that we know who to watch out for the letting people into the Google Meet at the right time. So, and then there was a question in email for logistics for people in person, and I guess Doug, next couple days we'll want to send out the physical address so people know where to drive to. Yeah. Not just the coordinates for their robot, but so that they can get a waypoint for their car.
No, I have it. I actually have a message already made for that.
Okay.
Yeah, Ted and all my strong competitors, they're going to go someplace. But anyway, no, actually, I'll send that email to you so that you have it too.
Okay.
That you can send it out to whoever needs it.
Okay.
And let's see.
Hey, for the registration there, if I'm gonna try to be there like virtually, should I pay? Say, can I attend or attend?
If you're going to do virtually, oh, wait a second. I sent the wrong one. No, I just put the wrong links in there. Just a second. I don't know what I'm doing. There's a form. That's what I meant to say. To RSVP, the preferred way. Here we go. This is the form I meant to send. That Google form is the best way. It makes a nice little spreadsheet. It asks all the right questions.
Well, I just finished the other one, Carl. Should I do this one too, or would that make a double count?
Yeah, well, the thing is the Evite doesn't have all the, yeah, the Google form is the best.
Okay.
Please, yeah. Wasn't able to decide on just one simple way, so we have like three. Okay. So aside from that, any other last minute questions about this coming up Saturday?
I think that one of the things we want to make sure everybody knows, if you're attending, bring a lawn chair, because there won't be any extra lawn chairs there. If you're a competitor, and you can bring a card table or something like that, that would probably, I'm not saying it won't be space on other people's tables, but that you probably want your own. Also,
I think you should be prepared,
Yeah,
I mean,
make sure you have your own power cord.
Yeah, make sure you bring your own stuff, because other people may have stuff, but you can't really depend on that, right?
Yeah, and tools. Make sure you bring tools.
I'm sure there'll be plenty of tools there, but you need to be self-sufficient.
And battery charger, if you need a battery charger.
GPS countermeasures.
Yeah.
In regard to power cords.
How did you know? How did you know I had flares? How did you know I had flares?
Flares, yeah.
In regard to the power cords, though, I should have enough.
A giant deep cycle battery with inverter.
Yeah. Yeah.
I'll bring the cords basically for 150 feet out.
Yeah, but that's really Kareem, I often bring an inverter to just stick in the car in case of an emergency. That's my big battery. That's the only one I got, but you know what I mean? If you add an extra battery, it might make it smart. So stick it somewhere. Let's see, is there anything else? Oh, you're going to find that if you're, what's happened in the past, if there's no pavilion or no place for you to set up your table, you got your table set up, you got your robot on it, you got your laptop on it, and you got the sun beating down right straight into your laptop screen. and you're not going to be able to see diddly. So if you have a towel or something that you can put over your head and over the lap screen, at least you can read the screen. I'm just saying that I've seen that happen before.
I'll have my parasol.
Yeah, that's a good idea.
Or else a box. That's what I use. And that seemed to work pretty decent.
Yeah.
For the laptop.
I just remember one year that Ron and I were both sitting out there. I think it was up at Paul Brochure's house, and we ended up, you just couldn't see the screen at all. And there's nothing you could, nowhere you could go. Okay, so is there anything else, Carl, that we need to touch base on?
I don't think so. Thank you, Ian, Ray, and Doug, for filling out the form. That's good. So at some point next day or so, I'll get a final count over to Steve, and I guess he'll order the goods.
Okay.
And,
now, there is one thing. John, you said you could bring a box of masks and and maybe some
cores.
Yeah, but a box of masks. You said you had a box.
I was going to bring a box of masks.
Okay.
Okay. All right. Right. That's good. Just so that we have, when things seem to be kind of flipping on us, a month ago, I would have said we're no way we'd had any problem, but now it's starting to look pretty weird. So
the main thing is indoors to get, though.
Yeah,
you're right. The number has gone up a little
bit.
So
we're probably going to make at least one trip over to Steve's house to use the facilities. So I would suggest that we have that box of masks.
Right, and that's why I would say for indoors especially, and outdoors. Outdoors more keep reasonable distance type thing. It shouldn't be too problematic.
Yeah.
It's the indoor air that's where the real problem comes in play.
Okay, so I'm actually bringing at least one young man and two young men, and they're going to, I'm hoping to get them to maybe handle videoing of this. Cool.
Oh, cool.
I mean, we'll see if we can rope them into it. So, but all, that way, the live stream, we'll have I don't think the live stream will be, are you going to, can you record the live stream? From a phone of the runs? We're going to actually try and go out there, right, on the runs. Somebody needs to try to record this so people like Pat just don't see us all gathered around at the beginning.
Yeah, I mean, we should be, if we use the Google Meet, then if we have enough cell phone to stream video on the Google Meet, then we can have I'll bring the recording laptop, same one as doing tonight, and I'll, whatever's presenting on the Google Meet, we'll have recording.
Okay, cool.
Yeah.
I'm going to bring a video camera and let them run that as long as they can. I don't know if my batteries are that good, but we'll see what we got.
Yep.
Carl, I assume I'm on your list of coming, right? Dave Ackley?
Dave, I got you. So I got Kareem, Doug P., Dave Ackley, Ted Myers, Pat C., Jack Jones, Harold P., John K., Ian P., Ray C., Doug D., CO, and there might be some others that came in by different mechanism. I'm not sure, but most are solo. A couple have 2 to 4 people maybe. So
okay, thanks.
We're still missing like Scott. Scott, I think, is coming for sure. I should reach out to Mr. Anderson. I thought he was going to come, but he hasn't. He's been off the radar for a little bit here, but.
So I've answered each of your different types of things, and I think I heard you say my name twice for Doug D.
Oh, Humble Mouth, Doug P and Doug D.
Okay.
I might have said you twice, but you're good.
Okay. I'm
Yeah, I
good.
think we
I
got
like
the
that.
regulars.
I'm going to go get my wife, and then you can repeat that. I'm good.
We'll put it in writing forever it's worth. I mean, yeah, Ron Dagdag. I haven't. We're gonna have to work on Ron Dagdag, Harold. He's not on the list.
He's got robots. Oh, wait. He's got robots too.
Yeah.
I mean, he doesn't have. I don't know if he's got robots that run in the grass, but he's got some smart robots.
He does.
Smarts going on his robots.
He does.
I will see him. I will see him tomorrow, and I will chastise him tomorrow for sure.
Yeah. Even just to visit, it'd be cool. But
yeah, just to visit would be cool. And he's got his kids. Bring his kids out. Maybe make some evil geniuses. All that kind of stuff. Awesome. Yeah.
Okay. All right. So back to the round table. We had the early speaker uppers talk about the robots and stuff, and we had some other people join. So if you haven't already mentioned anything about robot projects, either progress or questions or whatever, anybody like to jump in?
Well, I can give a little bit of update on me. I now coded up my robot to go forward. And then that's all it does. It doesn't really care. It goes forward. And we'll see if it gets close enough to a cone to get a point. The other thing is that I found a pretty cool thing that links a Trello board to a GitHub repo, and I've been playing with that. So basically, as you're entering things in the Trello board and your backlog, it creates issues in your GitHub. So as you fix them and you link them to it, it's supposed to link all back and move cards across and do fun stuff. So I'm playing with that a little bit. It should be fun. That's about all I really got going on. As far as my robot stuff goes, I'm mad at 52 Pi right now because they did this really cool little board here that I'm going to make my test boards out of. So when I start doing I2C and all my other junk to test out all the components on my robot, I'll have a nice, easy way to do that. And I've got a cool stack going on my Raspberry Pi now with screw terminals for all the GPIO boards, and it's supposed to fit right there on the thing. The problem is that all the standoffs they supplied with all of these boards are 2.5 millimeter bolts, and all of these heat set insets are 2 millimeter bolts. It's made by the same company. I'm like, what are these people thinking? Hey, so I ordered me a bunch of standoffs that'll fit, and they'll be here Monday. But that's just another bit of whining from me. I got the wine going on. It's a good year for wine, I think, or something. That's about all I got to say.
All right. Well, that's cool. Well, we're looking forward to see XMI in person driving under its own steam. That'll be neat. Yeah.
It'll go forward. And I got a button to stop it. So, and it don't go forward fast enough. I've not attached a lead, so somebody could disable the motors, even though there's a switch there. But I'm thinking, I think any of us can run up and touch that button. But if I got to really have a lead on it, I will put a lead on it. I got a tape. I've got a thread. It's all it takes because it doesn't. It's not going to take much. That kind of thing. So I'll make sure I comply with all the rules that I can.
Cool.
Kill switch can be a radio link, correct? So I'm using a button on my remote.
Yeah, I got that already. Not a problem.
So I have to hold the button for it to go in auto mode.
It works.
Oh, you got a dead man switch going on there, sort of thing.
Yeah, so you hold the button, it's in auto mode. If you release the button, it's in remote control mode.
Okay, so if your radio goes out of range, it just stops?
It just stops.
Awesome.
I've tested it. I've held the button, shut off the remote, and it stops. It times out after, I think it's a quarter second, and stops.
And there's not even going to be anybody there to damage.
Exactly. My wife, she'll be with me, so I think she's going to hold the dead man switch. And then I'll be on the phone and videoing it with another phone, probably.
Yeah, my robot goes so slowly that This is going to be a slow motion damage if it's a damage of anything.
That's
So
I'm not.
Harold, it's going to be like Office Space where the people are in the cars in the traffic jam and the guy is racing ahead with the walker.
Yeah, exactly.
Okay.
Exactly.
All right, cool. Well, thank you, Harold. So who else has something? Any other updates?
I'm seeking some advice.
Ooh, a challenge.
Yeah. So this is this showing?
Yep.
Yes.
So this is an image from an Intel RealSense D435 camera. The one on the left is a colorized version of the depth frame. And so my question is, what's a good way to extract features that represent objects that you should not try to run over or into? And my initial thinking is to simply either generate or try to capture a depth frame with nothing in it, and then use that as a background and try to remove that background, and then roughly anything remaining should be something that has foreground pixels in it. The original depth frame is not actually colorized like this. This is just, I think they do this in their examples because they want to support streaming formats. But the original depth frame is just a 16-bit, I think it's a grayscale image, although you can also query the points and get an actual distance to target in meters. But it's a lot of pixels, and I don't have a lot of horsepower in the host processor, so I'm looking for an economical method to detect the things that I should not be heading towards. And the purpose of the Coke cans in this image is to they basically outline a track that is wide enough for the robot to safely go through, and obviously they show the standard pyramid of the vanishing point in a straight line. But you can see that there's a pretty, wherever you don't have something, you have a pretty smooth gradient, and that's associated with the floor, basically. And then anything that departs from the gradient at that horizontal is probably an obstacle, and if there's enough of it, it's something you want to avoid. So I'm just I haven't even begun this process of experimented a little bit, but I haven't really begun the process of figuring out how to use this information.
With limited processing power, I assume OpenCV is out of the question.
Well, I'm using OpenCV, but and I'm downsampling to like 420 by 320 roughly size, and can downsample from there further. So I do have OpenCV on the platform. It's basically an Android TV box as the controller, but there's a limit and we're trying to do this for every frame. I'm getting these at 15 frames a second, and I'd like to be able to compute. There's a slight complication in that my camera is mounted on a balancing mast. It wobbles, and so there can actually be a twist. This gradient could shift. It could rotate a little bit from frame to frame, and that could create a problem if I don't sort of detect what the primary gradient is and correct for that.
Do you actually care about specific objects, or you're just trying to avoid stuff? You're just trying to not get too close to stuff?
Yeah, not get too close. Purely obstacle avoidance, no categorization, no classification, nothing like that.
Because the reason I'm asking is, although I haven't used this because I don't have a depth camera, but I know that in the RAWs world, and I'm sure there's an equivalent of that outside of it, there are packages available, solutions available for converting between RGB depth kind of image like you have, and the point cloud, and pretending it's all just a 2D laser scans. I'm just wondering if there's a way you can simply convert this whole data into something that's just more intuitive to process, right? Again,
So
I
I
work a
actually
lot
have,
with a 2D planar laser, and to me, that's a very intuitive way of dealing with it, right? Because you just get distance. So if you have a way of maybe converting this into a point cloud or even pretending it's a 2D laser, suddenly you might have data that's just easier to work with.
yeah, I actually do have a mechanism for turning it into a point cloud. But then you have to sort of rotate the point clouds. You still have the problem of identifying what the ground plane happens to be, right? And I'm not sure that I've found good articles on how to identify the ground plane and separate it from other things.
It seems like to me that's one thing you're assuming that there is a plane instead of some kind of undulating surface.
No, that's what that's exactly why it's difficult, is because it's actually an undulating surface, particularly outdoors.
Yeah.
Right? So there's some sort of continuity between the almost like a tension, perhaps, that you could use to compute what the ground plane would be. But they still have to have some sort of commonality, right? So the benefit of just looking at it as a depth map is that if you can subtract out what an empty frame would look like, you can basically just look at the gradient that would be there if there was nothing there and subtract that out. You don't have to compute the depth. You don't have to find the floor. That's the floor that you just subtracted out of it. But again, it does undulate real world.
Hey, Kareem, can you do like blob detection and reject the blobs that are below a certain level?
Yeah, after the fact, once I've filtered out the stuff I don't want to be looking at, yeah, I've got standard blob detection, all the other OpenCV filters. I'm probably looking at, I mean, there's edge detection. There's all sorts of different things that could be tried to identify. I'm probably going to need to use a Sobel operator to identify the primary gradient in order to sort of realign the image to what the reference image is for what a blank field would look like.
Right.
But whether I'm going to pull any of this off before Saturday is a real long shot.
Ooh, before Saturday, that is good.
Right. Well, I mean, that was the hope, right? That right now I have no obstacle detector on my robot.
Yeah.
Well, if anybody comes up with
hey,
yeah, go ahead.
Let me just throw one idea out. This is something Ray has actually played with. If you had a line laser that goes across,
yeah.
Okay, anything that's near, it's going to show as that line's going to be disrupted upwards, and anything that's further away is going to be disrupted downwards from standard. So if you looked at your color map, and if you just took one row of horizontal pixels and just look for differences in the color or the shade, you should know that there's something there in those locations.
Right.
Now, the problem is a tree. If it's in the middle of your field, everything looks like the tree. I mean, if the tree looks like something that's just a little like one of your Coke cans, you're not worried about it. What you're really worried about is when the whole field is tree.
Right.
So how do you handle, if you were to put this up against the wall, what does the signal look like?
It looks like one solid color.
One solid color, but it shows, so there's no depth so you get essentially a really good reading on the how far away that one color is.
Yes. I can convert that into a meter distance.
Yeah. So what I'm saying is, for big obstacles, you might just be able to use that fact.
The fact
that all of a sudden all you've got is one color. Everything, 70, you could put something like, if 50% of my distance is the same.
Well, that
I've
assumes
got
you run
something
into
from-
a planar object that's orthogonally
No.
right in front of you, right?
No,
Because
not
even
really.
even a tree is going to have a
round.
very yeah,
It's
it's
gonna be
round.
round.
Yeah.
Bark,
Yeah.
branches.
Well,
Okay.
you could put be tolerance it. You know what I mean? You
Sure.
say,
Yeah.
yeah. And if 50% is within 10% of each other, something's up there.
Yeah.
And if the distance is below 10 feet or whatever you want, wherever you want to trip it, I wish I could see 10 feet. Mine is, I think, 6, but 6. So, you know.
Oh
you
yeah,
can
this
say,
this
hey,
doesn't go that far. This will only go to about 2 meters.
Yeah. Okay. So what I'm trying to say is that might be useful. It'd be interesting to put it up against real world obstacles and see what the signal looks like and see if you could use the fact that 50% of your signal is within 10% of each other.
Yeah.
Or whatever. That would probably handle big obstacles. You know, if you go out there and there's a 1 inch tree that, bush that you're hitting, that might be a problem.
Hey, Kareem.
Oh, well, Kareem, why don't you just throw on, some sort of ultrasonic sensor or something for emergency, or a bumper?
Bumper's not a problem, but I'm hoping the robot's going fast enough where a bumper is going to hurt.
Yeah.
It's going to hurt it.
I understand. Yeah. I understand that. Okay.
Hey, Kareem, that camera does the. I thought you can look at individual pixel readings, right?
Yep.
Okay, so
every pixel in it has its own depth.
Okay. Yeah. So in the black and white image is the intensity.
It's an intensity representation of
the depth. Yeah.
So it's already been processed. It's actually got like 3 different cameras on it. It's got 2 infrareds and a color sensor.
Yeah.
And it takes the infrareds along with the projected laser, and that's how it gets the majority of its depth information. But then it spits out a depth map, and that's just a 16-bit per pixel representation of the depth. I've never actually seen it. It's not a format that is shown in any of the examples on how to export it, but you have to use I'm sure that's basically what it is. It's a linear depth representation that could be shown in pixels. So you should still be able to use image processing techniques on it.
Yeah. Okay.
Yeah, Carl, what do you got?
Okay, so I've just got some thinking out loud here. So you've got robot, right? And the camera's a known height above the ground. And then you say you've got it so that you can see maybe 2 feet in front of you. So it strikes me that, this is really hard backwards from the camera I'm using, but from the image of the plane, it seems like you can map, different parts of the image to, like, if it was a horizontal surface with respect to the wheels, you would expect the distance in the top of the image to be one number and the distance in here to be another, just from simple geometry, right?
That's the reference frame I'm talking about.
That's right. Okay. So, like, if it's all relatively flat and if it's going down, then you're going to know that you've got a declining surface in front of you.
Yeah. Mm-hmm.
And if it's all the same, then you're coming up on a wall. Or if it's even like a wall, will have a very different characteristic. So it seems like just from the basic geometry and doing like a grand average over the whole image, you could pretty quickly know if you're going to run into a wall or something.
Yeah, the question is where in the image that wall is, I think, is partly what I got to know. Like, I don't care if it's outside of the path that I'm following, right? If it's in that area that's outside of my vanishing point path, then I don't really care about it at that particular frame.
But that's just geometry, right? Because you can mask that out and just have the area of interest that you care about.
Yeah, exactly. And so the reference image would be that what it would look like if there was nothing there, if it were just plain flat, right? And then it's I'm thinking you subtract that using standard image subtraction from the current frame, and that gives you variation from that reference where you have an expectation of just a flat surface in front of you. And finding the blobs from that are above a certain threshold might be the way to go for this.
Yeah, and that's because another like thinking back to the Dave Anderson rule of don't worry about something if you know you can drive over it.
Right. Yeah. Exactly.
So it seems like you you should be able to estimate just from the geometry, like what's the size of an object that you can't drive over, and then you could use that to define the threshold for rate of spatial change of distance and magnitude of change of distance, right?
Yep.
Okay, well, that's the only thought I have. I don't know if it helps.
I appreciate it. Yep. Still don't think I'm going to pull anything off before Saturday.
You got 4 days.
No
day job, okay.
Yeah.
Can you select a region of interest in the image? Can you?
OpenCV supports square regions of interest, and they also support. It also supports masks, so you can ignore other things. So yeah, that can certainly be done. I think the rectifying the image is part of the problem also, right? So the reference frame would be like a still robot, perfect camera perfectly aligned to the horizon, that kind of thing. And then the actual frame, this mast is like gonna be wobbling around.
Ooh.
Right? So the whole, it bounces up and down. And so I'm gonna have to do something to correct that. Otherwise, I'm going to get a built-in, if using this differencing method, I would get a built-in false signal, I guess, unless I sort of figured out how to rectify that image before subtracting the reference image from it.
Or stabilize it. But...
Yeah, I could just get rid of the mast and just throw the thing directly, fix it to the robot. So
yeah.
I'm going to have to do some sort of workaround, I'm sure. Versus the preferred.
Looks like a good challenge. I don't feel so bad.
I had a question about the GPS RTK.
Yeah.
Did you ever use a one of the modules as the base? Like
I have not. I set up a base station successfully in South Padre, and I was using the standard SparkFun module. One of my modules has gone bad, and probably through mistreatment or something like that on my end. But it's gone bad, so I no longer have that. I have a development board from uBlocks that I just haven't had a chance to sort of break open yet. So I could possibly set up a base station if needed. The latest research that I've done is sort of said that long baseline. So any articles that you see about base stations, generally they give this like 10 kilometer as a distance, to try to be within 10 kilometers, right? And it seems to be pretty standard. But looking at long baseline RTK, it seems that the fall off isn't that bad. So, I've looked at studies where they say 50 kilometers, 60 kilometers, something like that. And you might lose like an extra 5 centimeters of accuracy. So my current plan is to use the publicly available VN1 station that's been running in Richardson, which is about 40 kilometers from the location. And so right now I'm referencing it on my robot. Now I haven't had a chance to in our new location to sort of characterize it yet, but I'm about 30 kilometers from it, 32 kilometers from that same base station, but it happens to be the closest one to me. And it seems like I'm getting good readings, but again, I haven't actually characterized them for accuracy or resolution recently. So in fact, I've got a problem with my, something seems to be wrong with my antenna. And I don't know if I crushed the lead in the antenna cable, but I'm not getting great satellite signal right now, and so I'm hoping I can find a replacement antenna in time.
Yeah. When you were setting up your, base station, I know like when you put it in survey mode, it takes a fair amount of time to, improve its accuracy to some level that is usable by the rover.
Yeah.
So like if you can run it 300 seconds, 5 minutes, and get down to like 1.5 meters accuracy. But that's not really good enough for like if you're trying to get centimeter accuracy out of the rover, you need to get the base station down at least to that level.
So I'm not 100% sure that that's true. So I thought that was true. In fact, there was a thread that I was looking at on the help desk forums at on the uBlocks site, and there's a direct question that's asked, and there's a expert on there who answers everything, and he's a customer of theirs, and he was basically saying that if you have an error in the base station, then that error is going to propagate linearly, right? To the rover. But then I found another a paper from Trimble talking about how accurate does your base station need to be, and they were saying you could get away with like a 10 meter inaccuracy, possibly. And so they were basically relating it to a parts per million drop in precision. So I don't even know that in like RTCM3 that that it's sending the actual location of the base station, right? All it's doing is sharing a propagation delay in an area that's near you. So I'm not 100% sure which is the truth. I'm not sure that it needs to be absolutely correct, but there was another post on that same forum where a person put in a graph showing a pretty standard curve for what the response time was to greater accuracy, right? And basically, once you get past 2 hours, you're getting into diminishing returns very, very quickly. And so the question is, for this particular, if you really want, if you want to set up a base station that's a reference for your house, I would let it go for 24 hours, right? Just let it keep on going until it gets whatever precision that you're going for. But if it's for a temporary location, I would, and your accuracy requirement isn't necessarily as high. Like for this particular competition, it's not that high, because we know that even though there's going to be a coordinate for the cone, the referee, judge, whatever, can place it anywhere within. What is it? Is it 10 meters diameter of that?
I think so. Is
it radius?
The idea is it's like a golf course green. Every day the guy walks out and he puts the cup in a different spot. So all you know is where the green is.
But is it 10 meters? So it's going to be somewhere within a 10 meter radius. Is it meters or feet? Or yards?
You'd have to look at the rules. I can't remember. But I will say,
them?
Yeah, Cream, I'll say one thing.
Yeah.
You know where the real accuracy, the real problem is the guy who's sitting out there and he puts the cone down. He's really going to try and put it exactly where it's supposed to be because he doesn't really know where he is. You know what I'm trying to say?
Right. Yeah. Exactly.
It wiggles around all over the place,
Yeah.
He's going to sit there and hope that, he's got a pretty stable signal and he's going to put it down there and hope that that's the right spot.
Well, if my robot is working and it has an RTK solution, then we could know pretty closely exactly where it is.
Yeah.
And then so you could put a flag there, and then you could decide, where from there you want to put the actual cone.
Yeah.
But I can't guarantee that because it's been acting flaky. Right now, I'd be happy to get it to move forward. So unlike Harold, I'm going backwards today. So.
With the GNSS modules. I mean, you don't even need a base station, really. I mean, you're going to be more than close enough to,
Exactly. Yeah. It's more accuracy than we need for this particular course.
Yep.
Yeah.
So are you saying if I put an RTK unit on my robot, I could tell them where the cone is supposed to be?
Yeah.
Yeah.
Yeah, you guys put the cone in the wrong spot. It should be
That's
way
right.
over here.
Hey, Carl, just one quick ad. I got a note from Dave Anderson, and he was planning on attending. So I don't know if he's on your list.
Okay, cool. No, he didn't do this, so I'm guessing he'll just come as a
Observer.
cheering on observer, but hopefully he'll bring his his bouncing robot or one. I know he's rebuilding his outdoor rover, so it's not working right now. But
yeah, what I'm just saying is that he did say I wanted to make sure he was on the list.
okay, good.
Okay.
Good.
Yeah.
Yeah, Kareem, the reason why I asked that, I was following SparkFun's tutorial on how to set up the modules.
Mm-hmm.
He does say that, I think he quotes U-Blocks and he says, 5 minutes at 1.5 meters should be close enough, to like see if it will work at all. And then later on, he does say that, if your base station is only accurate to 1.5 meters, you're not going to get centimeter level accuracy out of the rover. So I was like, okay, so I every time I set this up, I have to wait like several hours to see if it's for the base station that it's actually gotten down to that resolution.
So there's
and
two.
If I didn't, or it didn't, how could it be more accurate? I guess, like you said, maybe it's a statistical thing, but
well, there's two different problems there, and so the one that I haven't cracked yet is how accurate my robot is. I can know how repeatable it is, right? Yeah. I could let it sit there completely still, and I can look at the variance in position and figure out from one reading to the next how repeatable it is. Whether that actually maps to the right location on the actual Earth, you don't know that until you put your robot over a well measured reference point, right? Yeah. And so I gotta find one of those. But when it's in its top operating form, I do see that 2 centimeter roughly kind of repeatability at least.
Yeah.
And it's in the ballpark. So my best reference is to compare it to where it would be on Google Maps, right? Or on Google Earth.
That's what I've been doing, yeah.
Google Earth is usually the closest. Usually it looks pretty good. So
yeah, I've been impressed. It seems like it's, within a foot of where it needs to be, where it should be, according to Google Maps,
Yeah, but at that point, you're just, single pixels are like, about this, that big or something, in the best circumstance.
Yeah.
Yeah.
And it is, like the 6th and 7th digits are bouncing around a few counts,
right.
Up and down.
Exactly.
So
in fact, just today, I was thinking that what I really need to add to my telemetry is a constant comparison of the current location for the and using the distance to method to calculate it from the last location, the last update that it had, and just sort of plot that and see how variable it looks, so that I can at least diagnose if it's standing still, what is the resolution it thinks it's getting.
Yeah. I had another question about heading, and I'm hog all the time here. Do you actually have to move your platform to get an accurate heading?
Yes.
Okay.
Yeah, absolutely. You're not gonna get it any other way. And so there's two different things. So I'm not actually using the heading that is provided by the GPS unit, but the GPS unit needs to move in order to compute its heading. What I'm doing is I'm calculating the heading from different position readings along my path. And basically, so I have a calibration routine at the very beginning, where I just tell it to go on IMU. So just keep it going straight on the IMU for 10 seconds. Don't care how far it is. I just want to go for 10 seconds, going straight, and look at the difference in heading between the initial position and the end position, and that gives me the heading of my path, right? And then from that, I align my IMU to that reading.
Okay.
Somebody snoring? Is this boring?
It's like we're putting Carl to sleep there.
No, I'm sorry. Like I said, I got in really late last night, so I'm kind of a mess. More than normal.
Enough about RTK then.
No, that's okay. It's good stuff. It'll be fun to see it in person. I've only heard about it, really.
Yep.
Ray, I think you haven't gone yet if you wanted, and there's a couple others. So it's time to start speaking up if you haven't yet.
I can make one little comment.
What you got, John?
Do not get the tilt for the pith. That's what I've been busy working on. And this little part right in there, if you can see it, anyway, the hinge part, that is a pain to put together.
What is this? So, a pan tilt something?
Pan tilt for the Pixie.
A Pixie pan tilt. Okay, so you're saying the stock Pixie pan tilt, not so good.
Well, to put it together is a pain. It's taken a lot more time to put it together than I thought. So I'll show you
a lot of little tiny screws.
Oh, there's lots of little parts to it. I'll show you the step I'm at where, let's see, show screen, present. Okay, where's present? Present now. Render. Let's see, that's the one I'm working on, yes. So basically, this step right here took about half an hour to an hour plus to barely get it together right there. So I would say there are better tilts out there probably.
I don't know if you can see this or not, but this little tool is invaluable with those little teeny screws.
You have small screws, and then trying to get this real, these little things, these rubber spacer in there. I finally got it, but it took longer than I thought. But in theory, we'll see how well this really does, because what they show is, and I'll go to the other window now.
Murray's got one.
Ray, what is the name for that tool you held up?
Oh boy.
Yes.
I don't know. It's got like 5 wire whiskers on the tip of it, and the back end is just like a plunger to push them out, and it's spring loaded, so it basically will hold a screw so you can get the
poke it in the hole
started, and it saved hours of frustration and drop screws, and
they're just called screw retrievers in your standard computer toolkit.
Oh, is that what it's called? Yeah.
But
they're, I don't know, less than $10 at Micro Center.
For a claw.
Micro Center.
Here, I'll put a link for one in on Amazon.
Yeah.
9 of them for a 2-pack, 4 claw.
I just remembered something else I want to say. I've been tracking Adafruit for their B&O 55s and B&O 85s, and so this happened about a week ago for the B&O 85s. It happened today for the B&O 55s. So I get this message that says, "Hey, you've got an 085 ready to go. We have 300 of them in stock. Come get them." And so I go to hit them, and they're out. I mean, literally, we're talking here within an hour, gone.
Yeah.
And so the B&O 55s, 500 of them dropped this morning, gone.
Wow.
Just that fast. Yeah. So I hope everybody's got their IMU. That's what I'm saying.
I have all the parts. Now it's just putting all the parts together, the problem. But
4
in theory,
days.
tilt thing can do that. Their example is showing where they drop the ping ball, and it's moving around very fast.
Yep.
So we'll see if it's as good as that when it gets all put together. Hopefully by Saturday. So that's where I'm at. It's getting the hardware all together. And I'm about a day behind on that schedule.
All right, cool. John, very nice.
Let me get stop.
Yeah, stop. Yep, there we go. Okay, cool. And let's see. So, Chris, did I see you show up twice? Are you fixing to show something?
No, thanks for checking. No, I just had to get mobile, so that's why I'm on the second device.
Oh, no worries. Okay.
Nothing to report.
All right, fair enough. Well, it's good to have you on board anyhow. We'll send warm thoughts your way and see what you can find from the scrapyard to rebuild, or more robots to show us. That'd be good.
Soon.
Okay. Let's see. Working around. I think pretty much all we haven't heard yet from are Murray, Ed, and Molly. Do any of you have anything you'd like to share tonight or ask about tonight? Ooh, Murray's smiling.
Well, I don't have anything particular to report. I'm just continuing to work on my operating system, and I've got it now so that oh, by the way, I was going to mention one thing. That is, if I could find it, I have been reading I think it's about a 2008, I can't remember what year it came out, but Rodney Brooks of MIT Robotics Lab is one of the two editors on a book called The Artificial Life Route to Artificial Intelligence. And it's basically a compendium of different articles by different people about the behavior-based robotics work they did at MIT and the work that's been done subsequently since then. And I'm finding it like right up my alley in terms of behavior-based robots. And sort of Rodney Brooks has an article that sort of makes the argument for BBS systems and why his approach is valid and all that. And it's kind of gets right back to that whole subsumption architecture discussion and all that. And it's just really quite fascinating. I find it's an excellent book. Unfortunately, it's like $52 as an ebook. But yeah, but I've got a Kobo reader, so I went ahead and just bought it. But it actually has been worth it. I've been really finding it really interesting. And I've only got about halfway through. But one of the researchers that was originally one of his students, who's now I think she's a distinguished chair at USC, named, I'm probably getting the pronunciation wrong, Maya Matarik is one of his students she's now like a chair or something like that of robotics at USC. And she has got an article about some of the sort of post subsumption architecture work that she's done, which is trying to integrate higher level behaviors without sort of breaking the paradigm. So there's quite a lot in the book, and I'm finding it pretty fascinating. So I can highly recommend it to anybody. It is a bit of an expensive book to purchase, but worth it. And with that, the only thing I can report is that I've now got my OS so that I can actually, only on the bench, I've tried running it on the floor, but it's kind of pointless because it just runs into things like, it's a straight line test where if I put the robot on the bench, I can now put my hand in front of it and gradually move my hand towards the robot. And I had done this before, but it wasn't in my new OS. I can move my hand towards the robot, and as soon as it comes within a certain range, the robot will begin to slow down until I get to a certain point and it'll stop. So basically that's a behavior where the robot will be moving at full speed in roam mode. And then as it gets close to an obstacle, it'll gradually slow down and stop. And that's just a behavior. And so I've actually got that running now. So it's sort of one step at a time. That's one of the first behaviors I was planning, was a roam. It's just basically run forward until you run into something and then slow down and stop, and then something else would take over. But that's now working. And I'm also just in the process of putting an order in at Adafruit for an RFM 69. They're not LoRa. But it's a long range radio, a pair of long range radio transceivers, the little tiny boards that are SPI boards. So I'm going to try that out. I feel it's kind of cheating to be running a robot over Wi-Fi. So I figure that if I can come up with a way to do RFM 69 transceivers between a base station, which would probably be, where did I put it? It'll probably be my Raspberry Pi 400, and I'll have this be the base station, and I can then send control messages over to the robot. And of course, it's very, very low data rates, so you're just sending small messages, but it's kind of in the mode of the Mars rover, where you send small bits of information. You're not sure if they're going to get there. You've got to get, you know, that back and forth between the base station and the robot working in a very deliberately imperfect messaging. And so that's going to be kind of a challenge. So I'm just putting an order in for that because it sounds like kind of a bit of fun. And I think other people have worked with either LoRa or the RFM 69 radios on this in this group. That should be fun.
Yeah.
And my basement's still flooding, so I was
no.
mopping up mud this morning.
Oh boy.
That's it from New Zealand.
That's pretty
we're
cool.
back in lockdown. We're in level 4 lockdown. I'm not supposed to leave the house right now. So.
Oh my goodness.
That's what I heard. I heard you guys were locked down serious, like people getting serious fines because they're outside and talking to one another, and I guess they got too close or something. I didn't get the full details. People are going off crazy like that. Like there's got to be more details than that. But
well, if you think about it, we've existed since the entire thing started without any real breakout here, or outbreak, I mean, here. And so everybody's kind of got into this sort of complacency about what goes on. And we have been wearing masks on the trains and stuff, but this is the first time where we've got Delta in the country, and this guy wandered around up in Auckland, and he's infected at least 5 people and probably a lot more. So they've gone to level 4 to just lock it down, as the Prime Minister says, go hard and fast and all that, or go early and go hard or whatever. So they're just locking everything down because they're pretty sure it's actually spreading already. So we have an outbreak now.
Australia's infection rate is probably anywhere close to ours in the U.S.
Well, the thing is that the infection rate of Delta is something like, I think, 5 or 6 times that of the regular virus. So if you come in any contact at all with someone with Delta, you're much more likely to get it. So this guy just wandered around in Auckland, and they're not even sure how he got it. But it's now in the country, and it's probably an outbreak.
Population that's infected. So, as a percent of the
population
that's infected, we're much higher than Australia, but you guys are.
Yeah, but I mean, comparing New Zealand to the U.S. in terms of percent of population that's infected, I mean, come on.
No, we have five people.
They have 5, and they go into nationwide lockdown and to take care of it. We get 500,000. It's like, hey, you don't need masks in Texas.
Yeah. No masks.
The only one thing that was a bit scary is that one of those 5 people was a nurse, and she had been vaccinated. So,
yeah.
In any case, we're doing fine here.
That's good.
5 is fine, you know.
Hey, Murray, price notwithstanding, if you could put a link to that book or the name of it in the chat, that would be really cool. Because
tell you what, I'll send it into the mailing list. How's that?
Okay.
Yeah.
All right. Sounds good.
I really, really recommend it. In fact, on the Discord channel, I was just having kind of a discussion with somebody who's getting interested in building robots, and I was trying to explain sort of the difference between like an ExoMi or any of these Jetson bots or jet bots, which is, vision systems versus kind of like the behavior-based subsumption architecture. And most of the like ExoMi robots don't even have odometry, don't have motor control or motor encoders. That whole realm is just not available because you've got servo motors for motors and stuff like that. So you can't do odometry, and you might be able to do some form of visual odometry, but it's just a different form of robotics. And I was trying to explain that. And then on the other side, if you've got motor encoders and you can actually get precise velocity on your wheels and distance on your wheels, that's just a different path or a journey, as I was saying. And one of the things about this book is it really lays bare what the behavior-based robotics approach philosophically is about, why that's important. And it's funny because I'm ABD, all but dissertation, in a PhD program in knowledge representation. And that's the whole computer-based ontology thing. And it's funny because in this book, they talk very clearly about how disparagingly about knowledge representation. And one of the reasons I was not that interested in finishing my PhD was that the more I got into knowledge representation, the more I realized it was like bullshit. And that's kind of what the book talks about, is that it's ungrounded. It's not based on anything. And so one of the principles of behavior-based robots or robotics or behavior-based systems is they have to be embodied in a robot. They have to be situated in an environment. And they talk about intelligence, like animal, human, robotic intelligence, as requiring these things. So if you're doing simulations or if you're doing knowledge representation that's not grounded in reality, in physical reality, you're not really building a robot. You're making a simulation. And the whole AI world that doesn't ground itself in embodied, situated robotics, it's kind of in this abstract mathematical world, and it's not in any way grounded in reality. And that's kind of what the argument of the book is. And it's quite, and I can't make that argument as well as the book clearly, but it does talk about that kind of thing, and I find it pretty interesting.
Well, but AI systems work. I mean, you know, they're able to identify things in some cases with pretty good accuracy. So is that, you know, I would say that's very grounded.
What's that? Ray, your voice was really low.
Oh, I would say that, you know, AI systems can predict what, you know, objects are with, you know, in some cases very high percentages of accuracy. So is that, I would say that's fairly grounded. I mean,
well, here's the argument. This is exactly where Elon Musk comes in with his cars, is that can the car differentiate a person standing on the sidewalk from a photo of a person standing on the sidewalk? They can't. And an image of something is not the same as the something. And if you don't interact with reality, then an image can fool you. So if you are driving a robot on a carpet that has a photograph on the ground of something, you can fool the robot extremely easily. And that's part of the problem with driverless cars, is they're so easily fooled by visual phenomenon. And until you actually test a system like that in physical reality, which is now happening on our citizens, we're actually being tested on, and we're having people hit and killed by these things. They're going from this abstract concept of how these things should work in a mathematically modeled system. And in these little pixie cams and stuff, they're toys. And in the world of toys, that's fine. But when you actually try to ground something, and this is what Rodney Brooks and his team are talking about, when you actually ground it, you find out, and David Anderson is totally on this as well, is that until you actually build a real robot and drive it around, you don't run into the real problems that real robots have. And that's kind of what they're talking about. That you can talk about it all the time, and Murray can sit here in New Zealand and blab about robots, but until he's actually got a robot that's moving around and banging into things, it's just all talk. And that's kind of what they're talking about. And that's my biggest criticism of Elon Musk, is that he's all talk. He's basically a troll. His cars are now killing people because they're not grounded, and they're just trying to ground them. But I think it's a lot more difficult. And again, Brooks is one of the biggest critics of driverless cars as well, is that these systems that have been developed for decades are toys, but they're now being tested on people. So anyway, that's kind of
I'm less of a skeptic than you and David are. I think that like the best of the driverless cars are already safer than humans.
That's not an argument.
You talk, huh?
That's
absolutely,
not an argument. Safer than humans is not an argument.
If it's why is it not an argument? If you're better at driving, if your car is better at driving than you are, who should be in control?
So your argument is basically that all cars are better than driverless cars are better than humans, so we shouldn't be driving at all.
No, I said that they're trending in that direction, and the best of them are better than the stats that we have. If you look at like the Waymo stats, you have to question it. You have to be skeptical, right? They're a company that's trying to promote a certain thing, but you look at the stats versus what the real world accident rate is, and they're beating it, right? So, and they have hundreds of thousands of hours of real world experience. And by your own argument, they are running vehicles that are on the ground. They're real robots, and they're making these decisions. And yes, they can be fooled, but the rate at which they are fooled seems to be lower than the rate at which humans make mistakes from lapses in attention.
I would argue that every time you look at a movie shows you that you can be fooled.
You can always be fooled. Even humans can be fooled.
You say, yeah, right. I mean, you're looking at a movie and you think, well, that background is real. Those characters are real. You know, so
bottom line,
I could put a full size, you know, Arnold Schwarzenegger cutout probably on the side of the road and fool 50% of the people without any problem, you know, as they drove by. So I mean, I don't know if I buy the picture problem.
There's always going to be ways to fool
yeah.
any type of system, whether it's a human system or a robotic system, and it's just about getting better. And the primary thing to look at is the rate at which it's improving. It's getting a lot better at driving than humans are getting better at driving.
Bottom line goal, fewer deaths, fewer accidents, right?
Exactly.
Whichever one gets you there.
That's my Bugs Bunny cartoon where he draws the tunnel.
Oh, the hole in the wall,
yeah. You could be anxious about.
Yeah, but the robot has more available to it, right? The robot cars, they have depth sensors.
Well, I'm sure that Kramer and I can talk
it.
about this for a long time, but I simply will not. I mean, I'm not going to try to trump you with experience or anything like that, but I did spend 4 years in knowledge representation learning how much bullshit there is in that field.
Well, you're talking about formal knowledge representation, aren't you?
Yeah.
You're talking about formally encoded human expert systems and that kind of stuff.
The ultimate test is look at
that is not what we're talking about.
The ultimate test is look at insurance companies, right? Whatever their studies show is safer, that's what they'll insure.
That's right.
Well, I'm going to stick with Rodney Brooks on this one. He remains completely unimpressed with the field. And I think there's a lot of, yes, these things are better than humans. That doesn't make them viable. The fact of the matter is that if they're driving in rain, if they're driving on surfaces that are unusual, that would be unusual for a human, but a human can generally reason through an unusual situation, not always, but a car in those situations would be completely inoperable, like on snow, where the road surface is not even visible.
Have you seen Texans driving in snow?
I was going to say,
or in icy conditions.
Yeah, I've driven in ice. I've driven in lots of ice, and I can tell where the road is, but I don't think a robot could.
I have no problem 60 miles an hour driving down the road, a snow-covered road, and making it, you know, a few hours down the road. I doubt a smart car can do that.
I have a friend of mine that I worked with that his statement was, I could kill 50 people with freezing temperatures at Texas Highway in a bucket of water.
Hey, so if we disconnect ourselves from the, go ahead, Murray.
I was going to say this controversy is not one that we could ever resolve in this conversation. So,
well, it's ventured into the philosophical, and that's what I was going to say. If you want to get away from trying to have absolute answers in a philosophical discussion, there's this movie that we stumbled on not too long ago called Transcendence.
Oh yeah,
and I put a link that references an article to it, but it's a Johnny Depp movie. But basically, the guy downloads himself into some hardware, and then it gets really interesting. Then his body died, but okay, you have to argue and ask yourself, did he really die or not? As the movie goes on, it really, and you would say that by the end of the movie, he had certainly embodied certain things in himself.
Is that Johnny Depp? Was that a Johnny Depp movie?
Johnny Depp movie. It's called
I got it. Yeah.
Transcendence. I really enjoyed it, and y'all might like it too. But and then Wally was mentioning AI with David, where we just need a robot like that lasts for so many generations. It keeps on ticking, but
maybe Elon should take the thing. If your robot or your car can drive over it, it's okay. You can just drive over it. So it doesn't matter if it's a picture or a body. If you can clear it, then
You know, that's how it kind of works in the ocean. If they do the mouth test, if my mouth is big enough to eat you, I get to eat you. You know, so that's okay. You know.
Are you talking about David in the Aliens movie, the one that keeps killing off all the humans?
No, David Anderson.
No. Well, I think Molly was referencing David in AI, who's the boy who had a teddy bear.
Yeah.
That robot.
Boy, who had a teddy bear. I don't think I've seen that.
AI. It's another fun. Just let yourself just forget reality and go lose yourself in a movie. It's fun.
Well, okay, I'll make one final small statement that's not actually from me, and it's from Rodney Brooks. Is that he's predicted every year on his blog how long he thinks it will be before certain technologies come to reality, not testing but reality. And I just search Rodney Brooks yearly predictions or something, you'll find it. And he can make the case, and has certainly the authority to make the case much greater than I could. And he has a great article talking about how difficult it would be for a car to drive around simply in his neighborhood and make good judgments and not kill people. And like I said, I just Google on that, read it, or read this book, and he makes the case a lot stronger than I could. There's huge amounts of money lobbying for these driverless cars, and particularly for driverless trucks. And so there's a big lobby, just like there's a lobby for the petroleum industry saying these things are safe. I don't buy it for a minute. And having a little bit of background in the field, I even buy it less. And so we can't resolve it, but I'd say certainly read Brooks and what he's written about it and make your own judgment. So.
Okay, cool. All right, let's see. So anyone else? I still think so there's Ed and Kelly jumped on. Any updates for this week?
Well, I'm trying to finish my physical design of my rover, and I'm not leaving myself any time to work on the software, unfortunately. So
that's all right. One step at a time, eh?
Yeah.
Kelly, are you still bringing your robot lawnmower to?
I am, and I have gotten a little indecisive the last 2 evenings when it gets around to actually putting my computer in there and arranging my electrical components. So but yeah, it's mostly going to be a mechanical design. It's not going to be ready to take over the world or anything yet.
Okay.
So Kelly, are you coming for? Are you planning to come on Saturday and observe or bring some show and tell stuff?
I think he is.
You are? Okay.
Kelly, right? You're coming?
Yes.
Okay,
Yeah.
good.
Hey,
Do you
Kelly,
have them on the head count list, Doug?
No, I don't.
Okay.
But put them on yours. Are you gonna bring your bird observing robot just to show and tell?
Yeah, I could. Yeah.
I'd like to see it if you got room in your car.
Okay.
Say bird observing?
Yeah, I've got a little wildlife rover that I've used. It has some motion detection, and would just sit and wait for something to come along and take a picture. And I should get it charged up and all there and all too and all. But I do keep it in running condition and all. It's different than my mower project. It's kind of a finished project actually.
Those are some of the best.
I'd love to have one finished too.
My bird observing rover is a cat.
Mm-hmm.
Hey, Kelly, I just put a link into the chat. Could you just add your name to that form if you don't mind?
Okay.
Or email secretary@dprg.org just so we can get your name in the list and be prepared for logistics.
I just sent a message into the mailing list with a link to the book I was talking about and 2 of the articles by Brooks on driverless cars. So.
There it is. Cool.
And I would send it into the chat, but actually the chat is on my laptop and I'm working on my. I
I'll
only have
paste
one
it in the
screen.
chat for you. Okay.
Yep.
Okay, thank you. All right. Anyone else have any other topics you want to talk about? All right. Well, I don't have much of an update for myself. Like I said, I was out at my daughter's wedding. So there's been zero progress on this guy. But with any luck, I'm going to make it so where it can drive straight, turn around, and drive straight. And then if there's super duper luck, then I'll catch up with Raj in the next night or two, and we'll put a camera in here. But at the moment, I wouldn't have very high expectations for this duct tape and baling wire thing.
I've got a question.
What's that?
On interfacing an IMU with trying to drive straight.
Okay.
So basically, how much correction with the IMU when you're looking like a gyroscope are you using? You're on a straight path and you're bumping around in the grass, you're going around obstacles. How much correction do you add from your IMU to keep that going in a straight line?
I don't know about others, but in my case, in that situation, I would be dependent completely on the gyro readings. Otherwise, the gyro, just whatever angle it says you should be at, that's the angle you should be at.
Well,
I don't know.
I don't understand. Are we understanding the question right, though, Doug? I mean, Pat, are you saying if you're trying to drive straight based solely on the IMU or IMU plus other sensors?
I'm trying to drive straight, so I've got my PID loop, and both my tires are spinning at the same rate, or you know what I mean, to be going in a straight line.
Okay, wait a minute.
But it's not a real world. Because
No.
Can I ask a question?
Is
that going to like compass heading 37?
I'm attempting to go to compass heading 37, so I pick something and go.
So if your target is 37 and your IMU is saying you're at 40, I would say, and I have done this, so my suggestion of what I'm planning is take half the distance between what you are and what your target is. That moves you toward your target, and you gradually will get closer.
Yeah, you're talking about compass heading, but I'm talking about a gyroscope. So I want to keep going in a straight line. Yeah, I want to make sure I'm going in that straight line.
So you're going at 37 degrees, and and the ground is sloping 20 degrees, so your wheels are slipping a little bit.
Yeah.
So
there's a bump. There's a small patch ahead, denser grass. There's a million things.
Well, I think Doug Parody talked about doing some kind of almost like a PID loop over here.
Yeah, that's what I mean. So think of it this way. All right. The input of your PID loop has a summing loop, has a summing node. All right. And usually in just a straight PID, you've got a reference and you've got a feedback, and the feedback is negative into the summing loop. All right. Well, what you're doing is adding another arrow in. All right. Or you can, the usually way I do it is I modify the reference. Okay. So let's say your reference, you want to drive a straight line. So your reference is 0. All right. You want to go, you don't want any variation from your straight line. If you're off 0, you're either positive or negative. All right. But now that's not the question. The question is you're trying to go 37 degrees and you're at 40. All right. So what you really want to say is that my heading error is 3. So instead of 0, it's 3. Now, eventually, that's where David talks about your rotational section. Otherwise, you put that in your loop as a correction to your reference, okay? And so in this, let's see how I want to put it. So you have an input think of it, you have an input. You have an input which is coming off of your encoders. All right. You have an input that's also coming your heading degrees. So it's sort of like a loop around the outside of your speed control. Mm-hmm. And what you're trying to do is minimize your heading error. Mm-hmm. I don't know if I'm. So your speed is inside, and then outside you've got heading error that you're trying to correct.
Doug, I think you're presuming a certain architecture. Yeah. So I think we need to start with what's Pat trying to do. So Pat, it sounds like you're trying to use a gyroscope, and I presume a rate gyro. So its output is a signal in proportion to how much it's turning, right?
Yeah. So I'm lined up, and I'm not
a BNO 55. That's going to give him an absolute. That's going to give him a heading.
It's going to give whatever you want because it can do all of those different outputs.
Yeah, but I mean,
it can do all the different outputs. But when I'm heading straight, so I've got my target is straight ahead, and I'm driving in a straight line. So I don't want to. I've already issued my steering correction, and I'm on target. But now I want to make sure I stay on target as I go.
Okay, well, if you
controller for your steering is all it is. It's a separate, completely independent PID controller just for steering input. And you mix that with your speed to actually send to the motors.
And a lot of people have talked about this before. You don't necessarily need the proportional, the integrative, and the derivative. Sometimes you only need the P, but if you get an oscillation, then you'll probably add the D into it.
Yeah.
But you probably won't need the I. But we've actually, we have covered this before, and I think just a PD controller will probably give you that. A separate PID controller. Just get any. I think you're in Python.
Yeah.
I mean, just take a standard Python PID controller, but only put zeros in it on the I and the D to start with. Try the proportional. If that works, you're fine. If you have to add a bit of derivative so it doesn't do too much oscillating across the point, and you'll probably be done.
Yeah, well, that's what I was looking at, but I don't know if I'm going to count on the BNO 55 the compass angles being that accurate.
No compass. If you're going straight, you just want the gyro.
That's exactly. So I want the gyro only, and that's how I wanted. Okay, I'm not in a turn. I'm not correcting. I just want to go straight.
Yeah. If you want to know a specific heading, and otherwise, if you're just using odometry and a gyro, and you put your robot down, wherever you turn it on, 0 is what's in front of you.
Yep.
All right. So, but if you want to know that I absolutely don't want to go straight. I want to go to east. Then you could, and you don't know where you put your robot down. Then you got to have the compass or GPS or something.
Yeah. Well,
east is.
That's where I use essentially the IMU. I point the robot north. I know I'm north, and that's the way I start. So no matter which way the target is, point the robot north, and I know at least I'm in that direction. And now I can go with my odometry and go find my target.
What about the point that's south?
It turns around.
I'm just kidding you.
It knows how to do that. I chased it around my flower bed like 10 times.
You could add a simple slewing factor too. Like if you're in an airplane and you have a crosswind, then you might have to adjust your heading by 3 degrees into the wind so that you arrive at the right azimuth and everything. You can almost do that with yours to have some little correcting factors and all. If it's sloping to the left strongly, you might have something to sort of point up the hill a little bit, above your target azimuth. But a slewing angle is often used in airplane flights and sailing and all, where you could use if you're leaning one way or the other, just have a little slewing factor in there so that it could maybe go pretty close to right without correcting very much.
Yeah. I'm not too worried about that because the place I'm looking to reuse it is fairly flat ground. So I'm not so worried about slew. It's just it's one of my backup things that if I can't track right and everything is wrong, can I point it in a straight line and go?
Well, one of the advantages of a gyro or a gyro is that you do have 3 dimensions on that, so you can kind of determine, if you're at an angle or not. You can still keep a heading.
Yeah. So that's the plan, is to, if I'm going in a straight line, try to keep it in a straight line and issue some feedback.
Yeah, I like to use these tank treads and everything, and they really don't like slopes very much. So if you go up a steep slope at a 45-degree angle, you have to do a pretty measurable correction to get them to go in the desired path and everything. Slewing is something I'm kind of still working on, but I try to make my tank go up a hill perpendicular if I can. It's just to go where I want, and otherwise it'll curve and try and go down the hill, or it'll keep the heading, with GPS, but it'll be sliding down the hill sideways at the same time while still holding the right heading, So
I was pretty impressed by how many of those tank tread robots you've made, Kelly. You've kind of put quite a lot of experience with those.
Yeah, I've kind of learned the shortcomings a little bit, and ground clearance is kind of the reason why I went to the lawnmower. Then I wanted something that couldn't be stopped by a city curb and everything, or grass that was too tall. So, but I'm actually using tank type motor controls. It's four motors with four wheels with four motors and everything, and I'm using tank type of controls for it and for steering and all. So I'm kind of using old logic, but I'm gaining a lot of ground clearance.
So I'd be very curious. Excuse me. I'd be very curious to try. Excuse me. To see the approach that I have on a tank tread thing, then, because I think what I've done sounds like maybe what Kareem was alluding to on this guy. So I've got a B&O of 55 IMU in fusion mode, so it kind of can zero out inclination and still give you a true compass heading front to back, even if it's yawed from side to side. And even though it has the gyro in there, I only use its position output. So I don't look at the signal that's a rate of change of position. So the angular velocity, I look at the absolute angular position. So I have the absolute angular position as the reference into a PID loop. And then that's the signal I give from which direction I want to go. And then the feedback from the IMU says, well, this is the direction we're heading right now. And then from the air, I mean, I've got PD values, not the I, but I got PD values that then compute steering command for the wheels to steer the wheels more or less right or left or straight on. And what I found is that thing then, for as crappy as the mechanics and loosey-goosey as they are on this, it's really cool to see. It's really impossible to drive in a straight line with this controller by hand, like on a hill. But the PID loop has no problem. I can put it on a curb and it just drives straight as can be, forward or backward even. What's different is, what's interesting is that the gain, the PID loop gain for the steering wants to be different in the forward direction than in the backward direction. And I think that's because of the geometry of it all. And then the other thing is that the gain wants to be different depending on the forward velocity. So if it's going slowly, you want to have a higher gain. If the forward velocity is really fast, then you want to have a lower gain on the steering PID loop. So what I've done on this guy now, and what I hope to show on Saturday, is not an adaptive gain. So I'll have a fixed gain. So what it means is that the drive forward routine for this guy will be like critically damped at one forward speed, and then at slower speeds it'll be like underdamped, no, overdamped, and then at faster speeds it'll be underdamped.
Hey, Carl, do you think this is something that's specific to the Mecanum wheels, or would this also be true for normal wheels?
Oh, this is not Mecanum wheels at all. This is an RC card.
I thought you had it in the distance. I thought it was your Mecanum one.
Well, they all look alike now for me, but this is a 20 or 30-year-old RC outdoor racer, and it's got no feedback on the velocity on the wheels.
So why do you think that this is dependent on velocity so much? I'm
Same reason you don't turn your wheel hard when you're on the highway.
That's right. At 60 miles an hour, you'll flip over.
Okay, gotcha.
Yeah.
It's intuitively obvious when you think of it that way. But then, but to translate that, it takes a little think about it to translate that to, okay, oh, that's what the gain factor means when you scale the P or the D in the PID loop on a robot. So there's your embodiment.
That's as real as it gets.
So I'd be really interested to see how this performs on a tanked vehicle like that tread. Because I tell you, one thing I've learned with this, just in the little time I've spent, is that there's one approach which is to make your mechanics really precise, right? High precision, everything's perfect, everything's aligned perfectly. But then if you're relying on that, it's like the old rifles. Was it the old M1s versus the Russians? So the original U.S. rifles, you couldn't get them wet or they'd just fail. And the Russians, you could drag them through the mud, shake them out, and they'd just still work.
Yeah.
So this is the same thing. You get a really sloppy frame on here, and if you can get your control loops to take out all the slop in a sloppy frame and handle that pretty good, imagine how well they do if you actually had like high quality mechanics.
Yeah,
that's part of my excuse and my theory for doing a cheap frame like this first.
Solve it in software.
Yeah.
So if your model with your PID adjusting, if you're driving up a slope sideways, that maybe the lower wheels are going to make it spin a little harder to maintain that direction,
Yeah, it won't care. I don't think it'll care. I mean, that's what the magic control loop takes out. The PID loop takes care of it.
Yeah, that's the difference between yours and mine. Mine has dumb wheels, and on mine, I don't do any of that. So I try to adjust with the steering angle beforehand and everything, and hopefully it doesn't slip more than I expect or whatever.
But you could, right?
Right. Yeah, I
just
could
put an IMU in there and mix that in with the controls to the wheels, and
yeah, it'd be a little intelligence to add to it,
If you could buy them, because it sounds like they're not available right now, as Harold's found.
The B&O 80, I think the B&O 85 is available.
Well, they were just out of stock.
Well, I was just looking at Adafruit, because I get notified on those sorts of things. So I put it on there. I'm looking for one, but I think you can still find those things like Mauser and other places. I had noticed though that
No. The B&O 085, there's 35 in stock right now at Adafruit.
Okay, there you go. Snap them up.
Grab them. That's the only one they do have, by the way.
Yeah, those things have gotten expensive too. Like the 85. I remember those being like $20. I thought what's the going price on them right now? If you got it up there, Murray.
Well, no, it's not. No, okay. There was the original B&O 055, which was in a different form factor and was $35. Then they've swapped it down to a new form factor that has the stemma connectors on it, and those are $20. And the B&O 85 is also $20. So they haven't gone up; they've gone down in price.
I got you. Okay.
And they've consistently had this particular board on sale. And I know that Pimoroni has the BCM 20948, something like that. They have those in stock, but apart from that, pretty much everything's out of stock. There's a few of the 6 degree of freedom ones available, but if you want 9 degrees of freedom, it's the 85, and there's 35 in stock. There was 45 yesterday, so they've sold 10 since yesterday. And then Pimoroni has the, I think it's ACM, I can't remember the 20948, which is one of the nicer boards. I've got that. I like that one. And they have a few of those in stock too. But it's apart from that, I haven't seen anybody having any IMUs anywhere. It's kind of. I had an order in a basket with a Raspberry Pi 3B Plus in it, and I waited overnight. Oops. And it was gone. They had like I think it was like 50 of them, and they disappeared in 8 hours. So it's stuff's disappearing quick.
Mm. Oh, and another option too is Intel RealSense. They have some models with the I suffix on them, and that has a IMU built in, like the 435i.
They're not shipping anything until October.
Well, I ordered one from Amazon tonight and everything. So Amazon has some for retail
Oh,
price.
right. Cool.
And there's a rumor there that Intel may be shutting down their RealSense cameras. I don't know if there's any truth to it yet, but
it's probably likely.
Yeah. So I've actually got a regular 435 on one of my drones here, and I haven't even started using it. And I saw that, and I thought, oh, I want an I model, so I ordered a 435i. Because
the 455 has the IMU built in. Mm-hmm. There's no IMU model version. So and it looks interesting, but that's not shipping till October. Mm-hmm. But it should have twice the depth of the 435.
$250 camera just to get an IMU these days, right?
Yeah.
Well, the fewer components you have on your rover, the better, especially if you can integrate two things into one. It's a good option.
Well, cool.
It's okay. They're probably like cars now. You could probably sell your 435i for twice what you paid for it. Somebody's willing to pay for it.
Yeah, I thought about speculating on buying up some of those, but a lot of money though. A lot of risk.
One of the market on 435Is.
All right. So let's see. Any other topics we should touch on tonight? Today?
Oh,
when are we going to? Sorry, go ahead.
I did purchase a overly large package of orange cones. So if somebody's in the Plano area and you want a cone just for practice, I got like 12 of them for like $20. I could spare a few of them there if just wants one just for practice. In their own driveway, I can leave one out back, where you just pick up anytime you want in Plano.
Open invitation. Contact Kelly.
A lot of road construction out where I live, so I can do the go out and grab.
Kareem, you were going to say something, I think.
Yeah. When are we going to get the address?
Doug's going to mail it out. At what point? Next day or two, I guess. Doug.
I'll send it to you right after the meeting.
Okay.
Since you got the list, and I'll just let you go ahead and do that if you don't mind. I've got map link and everything. It's a 2-line text.
Cool.
So
I'll mail it out in the next day or two.
Yeah, I mean, I don't mean to shift that onto you, Carl, but I don't have the list of who's here going to be there.
Yeah.
And I'm building a robot too.
Yeah. Yeah, that's all right. I'll do it.
Okay, great. All right. So I'll send that to you right now.
Okay. Well, cool. Well, any questions, guys, that come up between now and then, just send it to the email D-list, or I'm always sending stuff from my personal email, so it should be easy to find. Just mail me directly or contact me. And until then, I guess we've got a whole bunch of screws to turn and soldering to do and compiling to do. So let's see what can happen between now and Saturday.
Should be interesting.
Try not to fry your motor drivers. That's all I can say.
And Carl, you said the event is going to be videoed?
Yes, we're going to, at least parts of it. I mean, it's an all-day thing. So we'll do our best to get the competitors and then the Zoom part for sure.
Be cool. I'd look forward. I mean, I obviously I won't be there, but Be nice to see what you guys do.
We're looking forward to see how a hybrid event works, since we haven't done it before, and well, we'll be figuring that out at the same time as we figure out how to turn on our robots. So
yeah, everybody just be patient, because I'm sure it's going to be kind of squirrely.
It'll be fun, but we'll have enough semi-smart people there, I think, and we'll figure something out, make it work.
I've got a 5 gigabit upload connection, so I'll have to see how it is to send a video. Pretty slow.
It'll get there. It'll be okay.
Okay. Yeah.
Cool.
Okay then.
All right, guys. Well, have a good night, and we'll catch you Saturday. Saturday. Good night.
Night.
Good day. Good night.